and thanks for joining us at the today's Spotlight seminar. This one is a fun one from my point of view because we get a chance to look at the development of the modern economy. We're now looking at extracting lithium metal from, in this case, brines, in order to fuel the future of transportation, which right now appears to be the use of lithium batteries in order to move goods and people around. So what we're going to see as I go through this presentation today is how we can extract lithium as the primary product, and maybe even some potassium and boron from a complex brine. And the brines we're going to look at today are a salar brine, or a salar located high in the Andes Mountains of Bolivia. Now, as it turns out, the Andes Mountains produces right now about 50% of all the lithium in the world, and I believe accounts for roughly about 70% of all the known reserves, or the producible reserves. What I've got here on the screen, in the center of our screen, is a table just showing some of the compositions of these brines. The one we're looking at today happens to be called Salar de Uyuni. It's located in Bolivia. We have to concentrate it up to about 4+ weight %. That means that we would need to concentrate this brine by about a factor of 50 in order to bring it up to about 4 to 5 weight % so that we can turn it into lithium carbonate and then sell it. Okay. In addition to that, we also have some other metals that we can produce. For example, there's potassium that we can sell as potash to the fertilizer industry, and there's even boron that we may be able to sell as well among other industries. So how then would we take this brine and convert it into lithium carbonate that could be sold to the battery market? Well, what we're going to do really is evaporate it. We're going to evaporate this thing by a factor of 50, or essentially by 98%. And we're going to do that in 54 discrete steps. Now, of course, I have the luxury of doing a calculation on a piece of software and studying the chemistry, so I can do 54 steps of separation. It may not be the ideal for engineering purposes, but by looking at it from a science standpoint, or looking at it from the chemistry standpoint, we can get an understanding of what properties the fluid has as we are evaporating it. So when it comes time to actually developing an engineering design, we understand what the pros or what the complications are along the way. And again, during all this time, we're going to do our best to minimize potassium and boron loss so we can also harvest those minerals. Now, in order to explain in more general terms how we're going to do this, I'm going to take my 54 separation objects and divide them into 6 major sections. The first 26 separators is going to be called the sodium chloride section. In these first 26 objects, during this evaporation, we're going to precipitate primarily sodium chloride. And really what we're going to do is we're going to add 1,000 cubic meters of brine to our separator. And then we're going to add air to it.